Hey guys, Casadia here. I just want to, touch real quick on how I got the printer, things leading up to it, and why I happen to be in a little bit of trouble now that I've gotten the 3D printer. It all started on a Sunday night, about 9 o'clock, 8:30, scrolling through Facebook Marketplace. Already a bad decision. I'm addicted to Facebook Marketplace. You guys will come to find out the more videos I make, it's gonna be me buying stuff, trying stuff, breaking stuff, and learning lessons the hard way. Pops up out of nowhere, boom, 3D printer. Do I need one? No. Do I want one? I don't know. Am I in trouble? Absolutely. Okay, hit the guy up, ask a couple questions. Is it stolen? Is it broken? Where'd you get it? He answers them, seems legit. So, how far are you? Only about an hour away. Look at the watch, 8:30 on a Sunday, work the next day. Hey, life's short. Hop in the car, start heading that way. I'm about an hour into the sticks. Train tracks, abandoned barns, creepy fields with wolves howling in the background. The GPS says, quarter mile. All I see, full moon, torn down barns, combine parts and trucks, and just the creepiest house sitting next to the train tracks with an old white guy on the porch. Well, I gird up my loins and I head into, head up to the porch. Here he is. I'm heading up to the porch. Talking to the guy, I reiterate, ask again, hey, where'd you get it? It's not stolen, it works. What's the word on it? He says, yeah, I buy pallets. It was on a pallet. Done deal. Hand him $250 cash. $250 cash. Jump in the car, an hour back. I get home. I start to unbox it. I get everything put together. I get the bed all nice and organized, start wiping it down, cleaning it with a little bit of alcohol. I take the SD card that it comes with, I push it into the 3D printer, warm up the bed, warm up the extruder, pick a print. This guy here, my dog, you'll see him. I picked the dog. He's the first thing I printed, my mighty little dog here. And that's when I realized that I'm in trouble. All right, guys, so if you couldn't tell by the video, I'm hooked. I love this stuff. I love it. Here's the torture toaster. This thing took about 26 hours to make. I made it even bigger than it was in the STL file. You guys let me know what you think down in the comments. Like I said, this is an Ender 5 Pro. This is a test print that kind of tells you how good your printer is at testing. I made a bit of a mistake here. Was a little too excited to get the toast out, and now the toast will never come out the correct way again. So this is what I should have done the first time. Kind of loosened everything up and actually worked the toast out a little bit. This one I took it to work. It just sits on the desk. And here I want to show you guys this too. I got a little too excited on the tolerance test. I knew the 0.1 tolerance wasn't going to open. On a lot of printers it doesn't. But I was determined to snap it off. This is made with PETG, by the way, so a little, actually no, this is made with PLA. I'm sorry. This is made with PLA. A lot of the white, actually all of the white prints that were made, that you saw in the video, were made with the original roll of filament that actually came with the machine. So there's a little bit of that one left, but you know, you get hooked, you get drawn into this thing. Gears move okay. They're decent. And if anybody's a pro on this, now I could have did a little bit more research when it came to this part. If anybody's a pro, tell me how this came out. 0.5 tolerance, 0.4 tolerance. The 3, we got some good movement. 2 gets a 2's moving good. 1 not ever gonna move again. That's there forever. I think the outside looks really nice, actually. It looks really good. Of course, there's a couple of strings down there in the gears. And then you guys let me know, like I said, if there's any pros, comment down below. How does that look, those degrees down in there? Of course, like I said, you know, I got a little bit of runaway filament inside. But yeah, guys, if you got the knowledge, let me know if this was a good test, a bad test, what I can do to kind of get some of those stray wires away. But I mean, all in all, I think it really came out looking pretty damn good. I don't know who broke that off. Idiot. And the top of the toast.
I don't need it. I don't need it. I definitely don't need it. I 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 need it!
So once again, on Marketplace, I found a really great deal. This is the newer F200 7-inch field monitor. I'm going to go ahead and put a link down below. So the monitor that I ended up getting did not come with the battery. So that's kind of where this whole video comes from here at the end. However, the one I have in the link does come with the battery. I believe there's another one you can kind of scour around and find the one without. And then if you want to use my STL file and go from there, you're more than welcome to do so. What I did find out from my research is the difference between the 100, the 200, and the Mystery 300. Okay, so the 100 comes in at a 1280 by 800 resolution. The 200 comes in at a 1920 by 1200 resolution, or what they consider on the box at least to be 4K. And the 300, I have not been able to find, neither on the web nor on Amazon. So if you guys find any information, once again, please link it down below. But I will definitely put the 200 model that I found down below. In any case, I did not have a battery to go with my field monitor, and I already got it at such a great deal that buying a new battery on a different platform and charging yet another battery just didn't sound sexy. So as you can see, this is the factory battery mount that came with the monitor. Clips in real easy in the bottom, already set up for me. When it comes to electricity, I'm not the sharpest tool in the shed. Now I can get away with a few tips and tricks here and there, but I will say my overall electrical knowledge is low. If we have any really smart electrically inclined viewers, please let me know down in the comments what the hell is going on here, okay? So I bought this amazing external battery charger. I love it. The link's also gonna be down below. It's called the Anker PowerCore 3. It's a 20K milliamp USB-C portable battery charger. And if I remember correctly, it said it could do something like 90 hours of battery charging. I haven't seen performance from it like that, to be honest. It does charge fast. It holds a great charge, and I do use it to charge my camera while doing recording. So if you guys are looking for something like that, it's a great option. And if you guys want any reviews on any of the stuff that you guys are seeing in this video, let me know down in the comments below. If you're liking the video so far, give me a thumbs up, helps out the algorithm. Consider subscribing. So back to the charger, each USB port pushes 5 volts. My idea was that if I can use 2 fast chargers and tie them together, I should be able to power the monitor. Cue the multimeter. When I plug in just one cord, I'm at 5.1 volts. My brain thinks, hey, just run 2 cables at the same time, you should get around 10 volts. That should be enough to power the monitor. But when I go to do this, the voltage drops in half. Please, smart people of the internet, in the nicest way possible, tell me what is going on here. Well, on to the next idea, I suppose. This is a generic battery charger that I have for my Panasonic batteries. I decided to take some inspiration from the design. Let's open her up and see what we have here. It looks to be real simple, 2 contacts on the back and 2 pins on the front. There's a little clip that snugs the battery into place. What I'm interested in here is the pin setup. Some glue, some solder, and the bending of the pins makes a nice and snug connection for the battery. The pins return back to position without any hesitation. This is the design we're building off of. So here's the idea. Take the base plate dimensions, the design of the battery holder / charger, and find a way to get the battery into it. So here's a look at the STL file that I came up with. I'm using a program called Autodesk Fusion 360. I'll put a link down below. Download the free trial, see if you like it. I think it's a pretty great program myself. I forget if you have to pay for it or not. I got it in a hurry and used my wife's school email for a student version. It's like $70 a month, I believe, for the paid version. So if it isn't free, or if my trial does run out for some reason on the student version, then you're definitely going to hear me complain about this in future videos. I took an AutoCAD class in high school. I wasn't too good at it, but when you want to do something on your own, and you have a passion for something, and you're the one who's given the passing grade, it's funny, you start to kind of enjoy the work. But this is what, just a real quick look at it. If you guys are interested on how to take the file and move it over to the printer, put it into a splicing program, stuff like that, let me know down in the comments. Keep in mind here, you're looking at the final version of the print. We're going to take a look at some earlier editions and kind of see the evolution. So the first print, the printer messed up the right side for some reason, and the top wall was too thin to hold the battery. I pushed the battery into it and it broke away right away. Also, I must not have had the heat settings right. The print just didn't really come out as good as it should have. Quality was nowhere near its best. The second print, I added a slot to get the battery out a little easier. Rounded the corners, kind of gave it a little sleeker look. and I made the top wall a little thicker. But as you can see on the right side, when I went ahead to go push the battery in, the right wall ended up breaking away again. Also, the detail that I had on the STL file underneath, I couldn't get it to transfer over to the printer. But third time is a charm. I kept the battery removal slot, made the corners a little bit more round, and I made the walls thicker all the way around. I used 2 clothespins, cut the points off of the clothespins, and bent them into that U shape that we saw on the battery charger. And those pins add a nice pressure to the battery, and they give a nice and satisfying click when you're inserting the battery. Easy to remove, and the wiring is nice and clean.